Welcome to What's New, your channel for everyday solutions.
Be sure to subscribe, share and like our videos. This is What's New.
Scientists may be a step closer to creating solar-fueled vehicles. Researchers are developing a practical method to convert water and sunshine into fuel. By Kavya Balaraman. Scientists are developing a practical method to convert water and sunshine into fuel, a key step in someday powering cars with the sun. Experts have long been experimenting with techniques to create solar fuels, which allow all the advantages of conventional fossil fuels along with the environmental benefits of renewable energy. However, this requires a photoanode, a sort of catalyst that can set the ball rolling, and researchers have had a tough time identifying them in the past. Now, scientists from the Department of Energy's Lawrence Berkeley National Laboratory and the California Institute of Technology think they've found a better way. If their experiments bear fruit, the results could revolutionize the renewable energy landscape. Electric cars with batteries are currently desirable because we have renewable ways of generating the electricity, said John Gregoire, principal investigator and research thrust coordinator with the Joint Center for Artificial Photosynthesis. With this renewable technology for generating fuel directly, you could have a bigger impact on renewable energy infrastructure. The process to create solar fuels essentially involves exposing water molecules to sunlight and breaking them down into hydrogen and oxygen atoms. The hydrogen can then be converted into hydrocarbon fuels or simple hydrogen gas. Photoanodes are key to this procedure. The job of the photoanode is to absorb sunlight and then use that energy to oxidize water, essentially splitting apart the H2O molecule and rearranging the atoms to form a fuel. And because this photoanode material needs to have the right sunlight absorption and catalytic properties, they're very rare, explained Gregoire. In fact, photoanodes are so rare that in the last 40 years, scientists have only been able to find 16 of them. Often, they are identified only when a scientist stumbles across some kind of material that absorbs light, and then thinks to look into its catalytic properties. Gregoire and his colleagues have come up with a new way to hunt for the catalysts, however, and it's much more effective. In 2 years, the scientists have already pinpointed 12 new photoanodes. A solar panel with a pipe. The technique used to identify the photoanodes uses a combination of theory and practice. The scientists worked with a supercomputer and a database of around 60,000 materials, and used quantum mechanics to predict the properties of each material. They then selected the ones that seemed most promising as photoanodes and used experiments to determine whether their calculations were right. What's special about what we have been doing is that it's a fully integrated approach, said Jeffrey Neaton, a physics professor with the University of California, Berkeley, and director of the Molecular Foundry. We come up with candidates based on first-principle calculations, then measure the properties of the candidates to understand whether the criteria we used to select them are valid. The supercomputer comes in because the whole database we're starting with has about 60,000 compounds. We don't want to end up doing calculation on all 60,000. This technology allows scientists a roadmap to find catalysts and eventually use them to create solar fuel. The final product, Gregoire said, would look something like a solar panel and involve 3 components: the photoanode, a photocathode, which forms the fuel, and a membrane that separates the two. It would be similar to a solar panel, but instead of wires with electricity coming out of it, it would have a pipe carrying fuel, he said. You can use it to power your vehicle. Picture a large device that collects fuel in a tank, and then you can fill your car from that tank. The finding, said Dick Coe, managing director of the Solar Fuels Institute, is significant particularly because of its screening process. To be able to take hundreds of thousands of different mixtures to see which ones have promise, and then do a little more to see the dozens which give you a hit. It really casts a much wider net in the world of different combinations of oxides and materials, he said. People do this for drug discovery. Pharmaceutical companies and biomedical researchers will try different kinds of molecules and see which one has the best reaction. Practically speaking, The technology also brings scientists a step closer to creating a solar fuel-powered vehicle. The nice thing about fuels and the reason why we still have a lot of internal combustion engines rather than electric engines is that chemical fuels have an enormous energy density. They're very easy to store and carry a lot of energy with them, a lot more so than batteries, explained Gregoire.
Welcome to What's New, your channel for everyday solutions.
Be sure to subscribe, share and like our videos. This is What's New.